Hello everyone. In this video, we will see how to use Atom to provision a set of VXLAN with EVPN mapping on spine and leaf switches, as well as creating a corresponding mapping for L3 routing with IRB bridging on the core router. This use case is realized using a combination of service model and workflow automation in Atom. The model also takes care of any VLAN provisioning on access switches, and the same will be mapped to the VXLAN using the service model. The service model takes user inputs which will then invoke a workflow, and the workflow will call the device model to complete the provisioning. This model will cater to the requirements of creating a new VLAN VXLAN mapping across spine, leaf, core, and access switches. It will also handle scenarios where we have an existing VLAN which can then be mapped to the access switches. Let's take a look at a scenario where we will create a new VLAN to VXLAN mapping. This will also create an access switch port. We have imported a template to complete the user form. As you can see, we have chosen a resource pool in the user form. Here is the resource pool we had chosen. The resource pool has one spine, one leaf, one core router, and one access switch in it. The service model will automatically identify the devices based on the host names, and the corresponding commands will be provisioned. For example, if the service model sees a spine keyword in the host name, corresponding spine commands will be provisioned. The other user inputs include VLAN ID, VRF name, route target if needed, and the trunk port will handle the port configurations where we are doing the core router mapping. We also have an IP address coming from the IP pool for the layer 3 routing and the corresponding gateway address. Moving to the access switch, we have the VLAN description and the access port where it needs to be configured. On the devices, we do not see the VLAN we are going to configure. Here is the spine, then the leaf, access switch, and finally the core router. As mentioned earlier, the service model will collect the inputs and invoke a workflow. The workflow here takes those inputs and generates the configurations for the access switch. If it's a new VLAN, which in our case it is, the workflow will generate the payloads for all spine, leaf, and core. If it's an already existing VLAN, then the workflow will skip the payload generation and ask for user approval. Once approved, the workflow will provision the commands. The workflow also takes care of deletion of the VLAN to VXLAN mappings using this flow. This is the subroutine we just saw in the main workflow for the access switch provisioning. The other subroutine is the command generation for spine, leaf, and core routers. The workflow will first evaluate the host names in the resource pool. Then, if it is spine, then we create the VLAN, the EVPN container, which is followed by VLAN VXLAN mapping and creating the protocol. If it's a leaf, then we create the VLAN VXLAN mapping only. If it's a core router, then the workflow will handle the creation of bundle interface, creation of the bridge domain, mapping the bridge domain to VLAN VXLAN, and mapping into the routing instance. Let us now apply the service. As you can see, the service model has invoked the workflow. We can see that the workflow is already waiting for the user approval. Claim the task and provide the approval. Once approved, we can see that the provisioning process has started. We can see that the service is now provisioned. On the spine, we can see that we have a new VLAN and VXLAN mapping and the extended VNI list commands. We can see the VLAN and VXLAN mapping on the leaf. And on the core, we can see VLAN creation, the IRB configurations, and has also added a routing instance of the RIB. We can also see that the VLAN has been added to the interface from where we receive the packets on the core. On the access switch, we can see the VLAN and interface configurations. We can also see the payloads that were generated on the Atom for these tasks. This is the payload generation for the core router, the one for leaf, the one for the spine, and then finally for the access switch. The deletion of the service triggers the workflow and it clears all the previously created commands on the devices. As you can see, all the configurations on the spine, leaf, core, and the access switch have been deleted. In case of existing VLANs, we need to identify the access switch where we have the VLAN created and then add additional access switches. Thanks for watching.